Hello, my name is Stephen Gottlieb, and I made up the GRE Math Prep video. At this point, I would just love for you to sit back, view a sample demonstration. That way you get to see a little bit of my teaching style. How about we get right into it? I wrote a problem on the board already. You're told that these x's, they're all integers, which must be even. Now, I just want to point out a couple of things. Numbers, or integers, they go odd, even, odd, even. If you want to start with even, they go even, odd. That is, if you start with even, and you keep adding 2 to it, which means you can add 2, or 4, or 6, or 8. If you keep adding 2, it'll stay even. Same thing with odd. If you have odd and you keep adding 2, it'll stay odd. But when you add 1, it changes. If you just add 1, it changed. You're odd, you add 1, it's even. When you add 1, it's odd. It changes. It changes from even to odd, or from odd to even. But anytime you add 2, you stick with what you started with. You start with even, and you add 2, and then maybe another 2, which meant you added 4, you add another 2, stays even. If you started with odd, and you keep adding 2, it'll stay odd. Now, what are the even numbers? The even numbers are 2, 4, actually 0, 2, 4, 6, 8, 10, etc. And they're all multiples of 2. 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, etc. They're all multiples of 2. Now, I know I gave this long lecture about adding 2 doesn't affect anything. We'll get into that in a moment. But you want to find one that's 2 times something. This one is 2 times something. 2 times an integer. Whether it be 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7. 2 times it is going to be an even number. And then you add 4. If you even and you add 4. 1, 2, 3, 4. You're even. This is done. There's your answer. Okay. But what if you weren't that quick? Well, if you start off with odd or even, and you add 2, you just get back to where you started from. That is, you can start with an odd, add 2, and get an odd. So this one's gone. Every time you add 1, you change from odd to even. Well, if you start with odd and you add 1, you're even, which is good. But if you started with even and you add 1 to it, you'll be odd. 4 plus 1 is 5. 7 plus 2 is 9. Those are not even. This is like this 3 times table. 3 times 1, 3 times 2, 3 times 3, 3, 6, 9, 11, 3, 6, 9, 12, 15. Only every other one is even. It's not always even. Now, whatever the parity is, parity means odd or even. So far the bottom will be the same. You add 2. 3x and 3x plus 2 have the same parity. Either they're both even or both odd. Now, if this was always even, or if this was always even, then that's always even. Which must be even? It's only one choice. So I can say right away that that can't be it. Because if this is always even, so is that one. And if that one is always even, if you're even and you take away 2, because you have 3x plus 2, you take away 2, you get back to 3x. Okay, but the bottom line is this alternates. 3x is odd, even, odd, even, odd, even. If you add 2, it's also going to be odd, even, odd, even. You add 2, you still get odd. You get even. You get odd. You're still even. You're still odd. So it's neither of these two, and this one works. You multiply a number by 2, it'll be even. Now you have to add something that's even. Or you can realize that if you have x plus 2, you multiply it by 2. That is, I factored out a 2. 2 times x is 2x plus 2 times 2 is 4. X plus 2 is a number. And like we said up here, it can be odd or even. But once you multiply it by 2, it becomes even. This completes the sample demonstration. I want to thank you for viewing this to the very end. And most of all, great success on your upcoming GRE exam. Thank you.